For all of human history, the journey from thought to action has been a story of physical translation. Consider the nature of a thought: an ephemeral flicker of electricity, a silent command whispered within the labyrinth of the mind. For millennia, this internal universe, a realm of intention, imagination, and will, has remained sealed within us, a private cosmos of silent potential. Our thoughts could only influence the world through the slow, mechanical intermediaries of our own bodies: our hands, our voice, our physical actions. It was the fundamental barrier between mind and matter, a division that defined the very limits of human capability. But what if that barrier could be dissolved? What if the silent language of our neurons could be translated, understood, and broadcast directly to the world around us? What if the mind could awaken the machine? That question is no longer the domain of science fiction. We are standing at the precipice of a revolution, a paradigm shift so profound it will redefine our relationship with technology and, perhaps, with ourselves. This is not merely an evolution. It is a fundamental re-architecting of interaction itself. The age of mind-controlled machines has begun. This is the dawn of neurorobotics. At its core, neurorobotics is the direct communication pathway between the human brain and an external device. It is a hybrid science, a convergence of neuroscience, robotics, and artificial intelligence. Using interfaces that can read the brain's electrical activity, the very signatures of our intentions, we are learning to bypass the body's physical pathways entirely. This process, known as a brain-computer interface or BCI, deciphers the neural code for movement, choice, and focus. For the first time in history, humans can move robotic arms with the fluidity of their own limbs, control advanced exoskeletons to walk again, pilot drones with a flicker of concentration, operate complex software without touching a keyboard, and command entire systems of interconnected devices, using the brain alone. This is not a distant future glimpsed in films. This is not a theoretical concept confined to research papers. This is happening now. In laboratories and clinics across the globe, pioneers are translating the intricate electrical symphony of the brain into the digital language of machines. The technology is rapidly evolving from bulky, experimental rigs into sleek, wearable devices and even minimally invasive implants. Each iteration brings us closer to a seamless fusion of human and machine, making the interface more intuitive, more responsive, and more integrated into our daily lives. The implications are staggering, touching every facet of human existence. In medicine, neurorobotics offers the promise of restoring mobility to those with paralysis, replacing lost limbs with prosthetics that can not only move but also feel, and offering new avenues to treat neurological disorders. It represents a profound leap towards overcoming physical limitations imposed by injury or disease. In industry, it heralds a new era of human-robot collaboration, where a worker's intent can guide powerful machinery with unparalleled safety and efficiency, transforming manufacturing, logistics, and exploration into realms of pure cognitive control. For society at large, it opens up new frontiers in communication, art, and entertainment, allowing us to interact with our digital world in a way that is as intuitive as thinking itself. But this incredible power brings with it a host of complex and urgent questions. As we create a direct interface with the mind, what becomes of privacy? Who owns the data generated by our thoughts? How do we protect the most intimate part of ourselves, our very consciousness, from being hacked, manipulated, or commodified? As these technologies become more powerful, where do we draw the line between therapy and enhancement? Between restoring function and augmenting humanity beyond its natural limits? A global race is underway, with nations and corporations investing billions to lead this technological frontier. The decisions we make today about ethics, regulation, and access will shape the future of our species for generations to come, defining the very soul of our connected future. In this series, we will journey to the forefront of this revolution. We will meet the scientists decoding the brain's secrets, the engineers building the machines of tomorrow, and the people whose lives are being transformed by this technology today. We will explore the breathtaking breakthroughs, confront the ethical dilemmas, and gaze into the future of a world where the boundary between thought and action is vanishing before our very eyes. This is a story about more than just circuits and code. It's about the next stage of human evolution. Welcome to the world of neurorobotics, the ultimate fusion between the human mind, artificial intelligence, and robotic systems. The mind has awakened, and the machine is listening. Imagine a world where your thoughts don't just stay in your head, but become immediate, tangible actions. A world where the boundary between mind and machine simply dissolves. At the intersection of biology and technology, a new frontier is rapidly unfolding. It's a field born from a question as old as science fiction itself. What if we could bridge the gap between the human mind and the machine? This is the world of neurorobotics, a discipline dedicated to creating a direct, seamless dialogue between our thoughts and the world of technology. For generations, this was the stuff of fantasy, the power of telekinesis, the dream of a mind unbound by physical form. Now, it is becoming a scientific reality. It's more than just an engineering challenge. It is a quest to redefine the very limits of human capability, to restore what has been lost to injury or disease, and to augment our interaction with the world in ways we are only just beginning to imagine. The science begins with the most complex object in the known universe, the human brain. Inside our skulls, nearly 100 billion neurons communicate through a dizzying dance of electrical and chemical signals, forming trillions of connections. Every thought, every memory, every intention to move a muscle generates a distinct electrical signature. When these neurons fire, they produce subtle electrical patterns that ripple through the brain like a storm. For decades, these intricate signals were a locked black box, their language a seemingly unbreakable code. But now, we are learning to listen. The key to this translation is the brain-computer interface, or BCI. A BCI is a device designed to eavesdrop on the brain's symphony of electrical activity. Some are non-invasive, like caps studded with electrodes that read the cumulative hum of brainwaves through the scalp. A safer but less precise method. Others, far more precise and offering higher fidelity, are surgically implanted to listen directly to the chatter of individual neurons. Regardless of the method, the goal is the same: to capture the raw data of our intentions at the very moment they are formed. But capturing these signals is only the first step. The raw data from the brain is incredibly complex, a storm of noise and information where the signal of intent is buried deep. This is where the second pillar of neurorobotics comes into play: artificial intelligence. AI algorithms, specifically deep learning models, are trained to sift through this electrical chaos. Think of it as teaching a computer to find a single voice in a stadium of shouting fans. The AI learns to recognize the specific, repeatable patterns associated with distinct thoughts. For example, the neural signature for imagining clenching your right hand is different from the one for imagining opening it. Through a process of calibration and repetition, the AI decodes them, becoming a powerful interpreter that can translate the nuanced, analog language of the brain into the precise, binary language of computers. Once the AI decodes an intention with sufficient confidence, it sends a command, and machines respond instantly. The entire process, from thought to action, can occur in a fraction of a second. This revolutionary potential has ignited a global scientific race. Around the world, laboratories in the United States, Europe, and Asia are racing to create a direct bridge between the human mind and robotic systems. From university basements to the research and development wings of tech giants, brilliant minds in neuroscience, robotics, and computer science are converging on this single goal. This interdisciplinary effort is crucial, as breakthroughs in one area fuel progress in others. A more sensitive sensor developed by a materials scientist can provide cleaner data for a computer scientist's new algorithm, which in turn allows a roboticist to design a more responsive limb. They are driven by a shared vision, a future where technology is not just a tool we hold, but an extension of our own will. This isn't a distant dream. The foundations are being laid today in countless labs, with every new algorithm and every successful trial. The most profound impact of this technology is in the field of medicine. For individuals who have lost mobility due to paralysis, amputation, or neurological diseases like ALS, Neurorobotics offers a radical new form of hope. Consider a patient with a spinal cord injury, unable to move their limbs. The connection between their brain and body is broken. By implanting a BCI, researchers can create a neural bypass, routing the brain's commands around the damaged nerves entirely. The patient simply imagines the movement, the BCI reads their intent, the AI decodes it, and a robotic exoskeleton or a prosthetic limb carries out the command. It is a technology that promises to restore not just movement, but autonomy, independence, and dignity. We are witnessing the first generation of people to control advanced prosthetics with nothing more than the power of their thoughts, turning a flicker of neural activity into tangible, meaningful action in the world. But the applications extend far beyond the medical realm, promising to reshape our relationship with technology in every aspect of life. In industry, a worker could control heavy machinery with unparalleled precision and safety, simply by thinking. In exploration, a geologist could operate a rover on Mars as if it were their own body, feeling the texture of the terrain through sensory feedback sent directly back to their brain. It promises a future of seamless interaction, where the cumbersome interfaces of keyboards, mice, and touchscreens are replaced by the speed and intuition of thought itself. This is the fundamental promise of neurorobotics, to dissolve the boundary between us and our tools, creating a true symbiosis where technology becomes a true extension of the human body and mind. The journey is complex, and the ethical questions are profound, but the path forward is being forged, one neuron, one algorithm, and one robotic movement at a time. Neurorobotics is transforming medicine. Patients who were unable to move for years are now controlling. Robotic arms, advanced prosthetics, neural exoskeletons, virtual limbs in real time, using only their thoughts. This is more than recovery. It is the birth of a new chapter in human health. A new generation of neural implants is connecting brains to machines with unprecedented accuracy. Some systems are implanted surgically. Others use blood vessels to reach the brain safely. With these interfaces, patients can move cursors, type messages, control apps, interact with devices just by thinking. This is the beginning of mental computing. Industries are testing robots operated through brain signals. Soldiers in experimental programs are controlling drones and robotic platforms without touching any device. Factories are exploring neurorobotic operators who manage multiple robots at once. For the first time, the human mind becomes a command center. Artificial intelligence is amplifying brain signals and predicting intentions before the user even acts. Machines are starting to understand what we want, not through buttons or words, but through neural patterns. This hybrid future will merge AI and human cognition into a single system. With this power comes danger. Brain data may become a new currency. Neural hacking could become a new form of cyber warfare. And the question emerges, if machines can read our thoughts, who controls our freedom? This is the greatest ethical challenge of the 21st century. The United States, China, Europe, Japan, and India are competing to dominate neurorobotics. The country that controls brain-machine technology may control the next era of industry, medicine, and military power. A trillion-dollar neurotechnology economy is rising. Humanity is crossing a threshold. It's a moment we've glimpsed in science fiction for a century. a frontier whispered about in laboratories and philosophy classrooms. But it is no longer a distant dream or a speculative fantasy. It is here. Throughout our journey, we have witnessed the dawn of this new era. We've seen the fundamental principles of neurorobotics, the intricate dance between our biological neurons and sophisticated artificial systems. We've celebrated the medical miracles, the paralyzed individual moving a robotic arm with a thought, the restoration of touch for an amputee, the silent world of the locked-in patient opened once more through a brain-computer interface. These are not just technological achievements. They are profound acts of restoration, of giving back what was lost. They represent the very best of our ingenuity, applied with compassion and a deep desire to heal. We have explored the different paths to this future, from non-invasive headsets that read our brainwaves from the surface, to the delicate micro-scale implants that listen to the very whispers of our individual neurons. Each path carries its own promise, its own set of challenges, its own unique dialogue with the human brain. We've seen how these technologies are already moving beyond the clinic, allowing us to control drones with our minds, to operate complex machinery with unprecedented intuition, and to interact with our digital world in ways that were previously unimaginable. This is a revolution not just in what we can do, but in how we can be. Machines are no longer outside us. For millennia, our tools have been extensions of our bodies. The hammer an extension of our fist, the wheel an extension of our feet. But this is different, fundamentally different. They are becoming extensions of our minds. The boundary between thought and action, once separated by the complex machinery of our nervous system, is becoming a direct digital bridge. This integration is creating a new form of cognition, a hybrid intelligence where our biological creativity can be amplified by the processing power of silicon. Imagine an architect visualizing a building and the blueprints drafting themselves in real time, a scientist contemplating a complex molecular structure, and a simulation instantly testing its properties. This is the promise, a world where the speed of imagination is the only limit. But as we weave these digital threads into the fabric of our consciousness, the line between the self and the system begins to blur. When a part of your memory is stored on a chip, or your emotional state is monitored and modulated by an algorithm, where does the organic you end and the artificial you begin? This is not just a technological integration, it is a philosophical one. We are not just wearing our devices, we are merging with them. The interface is becoming invisible, dissolving into the very essence of our being. The question is not whether neurorobotics will change the world. That is a certainty. The echoes of this revolution will reshape everything. It will redefine medicine, transforming it from a practice of intervention to one of restoration and even augmentation. It will change the nature of work, creating new industries while making others obsolete. It will alter how we learn, how we communicate, how we create art. The potential for good is immense, almost blinding. A future without paralysis. A world where neurological diseases like ALS or Parkinson's no longer steal a person's ability to interact with their loved ones. A society with greater accessibility, where physical limitations no longer define a person's potential. This is the world that neurorobotics offers us. It is a future worth striving for, a testament to our species' relentless drive to overcome, to improve, to transcend our limitations. But to accept the promise, we must also confront the peril. We have discussed the ethical minefields, the sanctity of mental privacy, the potential for cognitive manipulation, the specter of neural hacking, and the profound question of consent in a world where our thoughts are no longer our own. These are not abstract concerns. They are the guardrails we must build now, before the technology outpaces our wisdom. The question is, will we remain human in a world where our thoughts can command machines and be read by them? What does it mean to be human when our minds are connected to a global network, our experience is shareable, Our very consciousness potentially quantifiable. Will this new frontier lead to an unprecedented era of empathy and collective understanding, or will it create new forms of inequality, a divide between the enhanced and the unenhanced? The answer is not preordained. It will be written in the choices we make today. It will be shaped by the regulations we enact, the ethical frameworks we build, and the public conversations we encourage. It requires us to be not just brilliant engineers, but wise philosophers, not just innovators, but guardians. We must proceed with a spirit of hopeful caution, embracing the potential to heal and connect, while fiercely protecting the autonomy, privacy, and dignity that define our humanity. The path forward is complex, but the goal is clear: to use these powerful tools to amplify the best parts of ourselves, our creativity, our compassion, our curiosity, without losing ourselves in the process. We stand at the beginning of a new chapter in the human story. The tools are in our hands, and the thoughts are in our heads. The future is not something that happens to us. It is something we will build, one connection, one thought, one choice at a time. This is the new frontier. This is Neurorobotics. The story of humanity has always been a story of tools, of extending our reach beyond the limits of our biology. But this is the final tool, the one that reaches not outward, but inward. It is the tool that will define our next evolution. And it asks the ultimate question: what do we want to become?